The plan for this evening is to test fire the laser. Because the display doesn't work, we cannot easily just use the menus to do this, and I'm not sure we want to anyway, because the fault from the previous owner said that it was intermittently firing, which suggests that maybe an interlock on the controller board, such as the lid or the front cover, was preventing it from firing. So we've got the laser power supply with this connector. This is a 15-pin D, and it breaks out to a 25-pin D. I found some descriptions of the D1000 power supply, which this is a D600, on the website of Coherent, and they list the pinouts. Tracing the pinouts, it seems as though the connections that are made here make a lot of sense. I'll put the info up on screen, along with a diagram of how I plan to test the thing. I've made myself a little connector, and I've got a little bit of a patch board, and we're going to connect the connector up to the patch board. We're going to set 5 volts and 0 volts to the board from the laser itself, and we're going to try and hit the enable pin and the fire pin and see what happens. Inside the case we have a random piece of wood under the lens, and around the back we will attach a current clamp around the positive leads going to the power supply to see if the current spikes as we fire it. Let's get it set up. We now need to find a 5-volt supply so we can tag the enable pins and the fire pin. So let's probe around and have a look. We know that the case is logic ground, and we've also got a logic ground on our board. So what I'm going to do is I'm going to tap off the logic ground from the test board we were using. I'm going to poke around the logic board and see if we can find 5 volts. I'm going to guess that that connector there is probably got 5 volts on it. 4.97 volts. Now that might be a logic high, which should be fine because we're not powering anything with this 5 volts. Okay, so those are both 4.97 volts, you see. Right, I'm going to go and get a push connector to put on there, and then I'll wire it up to our test board. Just double check. Yep, top right pin. So this is where I try and test the laser. Originally it was wired up so that it accepted a differential signal on the input. This means it had 2 wires, positive and negative, and it would alternately pulse them to turn the laser on and off. It does this at a very high speed, I believe about 20,000 times a second. If it's on for 50% of the time and off for 50% of the time, that's half power essentially. If it's on for 90% of the time and off for 10% of the time, that's 90% power. So I tried to get it working like this, enabling the laser with the enable pin that was listed in the sheet, and just tapping these pins. Didn't work at all. So what I then did was change the mode. There's one pin that's got a mode select, which is differential lines, or single line, which is TTL logic. So I swapped that over so there was only one pin that would need pulsing to turn the laser on. Set the enable pin again and pulsed this on and off. Now I can't obviously pulse it at 20,000 times a second. What I did is I just plugged it in, which would be essentially on all the time, which is 100% power. I didn't get anything from this, although I did notice a very high-pitched whining sound when I connected the pin. This is what happened next. Okay, I think we might be starting to fire. Still doesn't work properly, but I've reconfigured it to TTL logic input. If I take the negative TTL logic fire, the pulse pin that's supposed to be PWM controlled, touch it to the positive logic, it jumps up to 1.36 amps from 0.45 amp, and something you probably can't hear on camera is a very high-pitched whining noise. So I think maybe the RF is being generated for the laser, and maybe the laser is broken. I'm going to turn it off, check the RF cable to the laser, and try again. There's definitely no burn marks on the wood, and as far as I'm aware, all the mirrors are aligned. They haven't been touched. Maybe I need to put a target directly on the laser output just in case. Let's do that. Okay, I'm going to check the error outputs now. I've got essentially nothing, and nothing. I'm going to connect my output enable pin to positive, so in theory it's firing. I'm going to check again. Nothing. I've got 2.8 volts there. If I disconnect that there, I've got nothing. If I connect it, so it's firing, 2.8 volt output. Interesting, okay. Right, let's disable it again and turn it off and look up what the green wire is. So I've looked at that pin and it is a general laser fault. Essentially what it is the power supply is detecting that there's too much reflection coming back from the RF feed to the laser. This could be a number of things. It could be bad alignment. It could be, as we thought, maybe it's just bouncing too much power into it and it should never run at full cycle. Or maybe the tube's on its way out or gone. It might be that the CO2 has escaped, but based on what the previous owner told me, that doesn't sound likely because it was intermittently coming on or off. I don't know how these internally align, and it's a pretty solid block of metal, as you can see. I can't imagine it's got any adjustments on it. You've got the laser head on the end, just there. Let's have a look. Which I do believe comes off and is separate, so I might dismantle that. So the next thing I can test is if I create a PWM signal to go into it and see if I can fire it that way. Otherwise, I don't know. I'm stuck. Either way, I want to carry on with retrofitting the new controller, the new motors, the new drivers. So let's take some measurements for the stepper motors and let's order all of the new controller board, the drivers and the steppers, and see what we need to butcher to fit the new motors into the old mounts.